This video is going to have a look at how to resolve a set of simultaneous equations algebraically using the elimination method. So simultaneous equations are where two or more linear graphs or linear lines have the same solution. So that means we're looking at where those two lines will intersect on a Cartesian plane, where the x and y values are going to be the same in both of the linear lines. You can solve linear equations either graphically by using a graph to identify the point of intersection, or you can do it algebraically using the substitution method or the elimination method. This video is going to have a look at the elimination method. How can we use the elimination method to be able to identify our intersection point to work out what our values of x and y are going to be. So let's have a look at the steps involved to be able to use the elimination method. So the first step in using the elimination method is going to be to rearrange the equations if required. It'll be required if we don't have a variable with the same coefficient in front of it. So one of our variables need to have the same coefficient. It can either be a positive or a negative number, but it needs to be the same number. If we don't have a variable with the same coefficient, we then need to rearrange, or we need to change the equation to be able to ensure that we've got that coefficient. So we might need to multiply each of those terms in the equations on both sides by the same number to be able to change the coefficient in front of one of the variables. So the next step will be to decide if we're going to add or subtract the equations together to be able to combine them. The third step is then to combine the equations together by either adding or subtracting, depending on what we decide in step 2. The next step is to solve the combined equation that we formed in step 3, and then that will give us the value of one of our variables in the original equations. Step 5 will then be to substitute in that known value into one of the original equations to find the value of the second variable. Then once we have the value of both variables, the final step is to write the answer. So that is a summary of the steps required to be able to complete the substitution method. Now we'll go ahead and have a look at an example. So in the example, we want to use the elimination method to be able to solve the equations. And the equations are 2x plus 2y is equal to 10, 2x minus y is equal to 4. So the first step is to have a look to see whether any of the equations need to be rearranged. And I can see here that in my first equation, I've got a 2x. In my second equation, I've got a 2x. So I've already got a variable with the same coefficient in front. So I don't need to go ahead and rearrange any of my equations. The second step is going to be to decide if I'm going to add or subtract the equations together. Now, because I've got a positive 2x and a positive 2x, when I combine my equations, I want those to cancel each other out. Because they're both a positive, I'm going to subtract my equations together. So the next step is going to be to combine my two equations together by subtracting them. So I'm going to start off with my first equation, and on the left-hand side, I've got 2x plus 2y. So it's going to be 2x plus 2y, and then I'm going to combine it with the second equation. So on the left-hand side of that equation, it's going to be 2x minus y, and I'm going to be subtracting that. So minus, and then in brackets, 2x minus y, and that is going to equal to going back to the first equation, I've got a 10 on the right-hand side. So 10, and because I'm minusing, it's going to be minusing the second equation, which is 4. So I can go ahead and simplify that and expand my brackets. So 2x plus 2y, and then it's going to be minus 2x, and then minus negative y. Minus negative y is going to be a positive y. So it's going to be plus y is equal to 10 minus 4, which is 6. So now I can collect my like terms, and here is when I get rid of my x. So 2x and negative 2x will cancel each other out. So on the left-hand side, that leaves me with 2y plus y, which is 3y, is equal to 6. So to get y by itself, I need to divide both sides by 3. So that means my y value is going to be equal to 2. So now that I know one of my variables, I can go back and substitute that into one of my original equations. I'm going to choose to substitute it back into the second equation. So 2x minus y is equal to 4. So I'm going to substitute in my known y value. So 2x minus 2 is equal to 4. So I can go ahead and solve that. And to do that, I'm first of all going to plus 2 onto both sides. So 2x is going to equal to 6. Then I'm going to divide both sides by 2. So x is going to equal to 6 divided by 2, which is 3. So now I've got my final answer. X is equal to 3, y is equal to 2. I can write that down as 3 and 2. So the point of intersection between my original two equations is going to be 3 and 2. So that is an example of how we can use the elimination method to be able to solve a set of simultaneous equations.